Hi, I'm Mr. Michael Fullington, and today we'll be talking about the law of sines and cosines, as well as the calculator process. So first, what do we use these for? Law of sines and cosines can be used to find any missing angles or sides in any type of triangle, except for a right triangle. Of course, in a right triangle, you can use SOHCAHTOA or the Pythagorean theorem. But in any other kind of triangle, we will use law of sines and cosines. When do we use these law of sines and cosines? So you must have three pieces of information about any given triangle. And to use law of cosines, there's only two cases in which we can use those. And that is side, 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 when we have all three sides, or we have side, angle, side, which means we have two sides with the angle in between them as given information. In all other cases, we will use law of sines. So here's the law of cosines. And as I stated before, there's only two cases when we use this. So it would be side, 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 or side, angle, side. So for instance, if we had side B and C and angle A, so the little b's and the little lowercase letters are the sides, and the uppercase letters are the angles in this instance. So let's say we have B and C. We would use the top formula to find A, or side A. So you're given that information, and then you just fill in the blank. So let's say you're looking for side B or C. You could do that for any of the following. You just use whichever formula corresponds. And then for law of sines, which we will use most of the time, you need just three pieces of information once again, but you only need to use two of these equations at a time. So if you have side A and side B, and then you have angle A, and you're looking for angle B, you would use sine A over sine B equals sine B, or sine A over A equals sine B over B. Okay, so let's do some examples. So as we reviewed before, these are the law of sines and cosines, and I gave you a little triangle right here that you can look at to reference. And here's the cosine rule right here, and this is the law of sines rule. So we're just going to start off with an example for the law of cosines. And we'll get this off the page. So law of cosines. Law of cosines. Okay, so we have a triangle here with angle A, or no. We'll make this B, A, C. We'll make this 105 degrees. We'll make this, these are sides. This is side A, this is side C, this is side B. So we have side C and B, and these equal 10, and let's say 12. So we will start it off by looking for side A, obviously, since we have a side angle side and we're missing side A. So we'll start A squared equals B squared, so it's 12 squared plus 10 squared minus 2 times 10 times 12 times the cosine of 105. So we'll simplify this to 144 plus 100 minus 120 times 2 is 240 times cosine of 105 equals A squared. A squared, or little a, sorry. So this equals 244 minus 240 cosine 105. Now here I'm going to pull up a calculator for you guys to look at on the screen. We'll see if we can get this to fit on the screen. So this is the calculator we'll be using. Standard scientific calculator. So as the problem states, cosine cosine of 105. So we'll do 240 cosine 105. Close that parenthesis, and we'll press equals. That's going to be negative 5783. Now we go back to the problem and we see that it's 244 minus that 5780. So it's 244 minus a negative, so make this a plus, 5783 or some change, and we'll look at the we'll get the calculator back out. So we'll put 244 minus answer. That'll bring this 5783 down. And you'll get 301. And as you can see, we'll go back to this. So that's going to make it a squared. So a squared equals 301.83 change. So we will take the square root of that. And we left it in our calculator because we want the most exact number we can get to find exactly what a equals. So go back to the calculator and we'll do the square root, this button right here, square root of the answer, close the parentheses, equals 17.37. So our answer for A is 17.37, and depending on how your teacher wants you to round, they'll specify that. We'll just go to the second decimal place, but but some teachers like the fourth. It just depends. Okay, so that's law of cosines. Let's move on to the law of sines. Now remember, law of sines, sine A over A equals sine B over B, and equals sine C over C. And remember, we need 3 pieces of information from our triangle. Let's make it a little bit different than the last triangle. Whoa. That's a big eraser. Okay. So we will start it this way. And we'll have angle A, B, C. Let's say we have angle A and B, and angle A equals 36 degrees. I'm not going to put it inside this triangle because it's awfully small. And this angle, we'll say, it seems a little smaller, so let's say it's 32 degrees. And we have side B as equaling 10. So we'll start it off as sine A and sine B. Sine of 36, and we're looking for side A. A is the objective. Sine and over A, and then sine B is sine of 32 over 10. Now, if you remember, we cross multiplies these to simplify and find our answer. So it'll be sine of 36 times 10 equals sine of 32a, and we will divide this by sine of 32, and we will plug this into our calculator. So let's start it off with, it's always better to keep it all together, so we'll close. we'll get rid of all that stuff we just did. We'll go, started off with parentheses, started off there, sine of 36, close parentheses, times 10, and then you'll do two parentheses to close that off, divided by sine of 32 on the bottom will give you a. So we get side A equaling negative 1798, and usually when we do that, you'll use that as absolute value. So side A will equal negative 1798. That's just a direction usually, so it'll equal A equals 1798. And that's how you'll do that. Thank you for watching. And if you have any questions, just leave them down in the comment box below. Thank you.